Hello there, I'm Mr. Math Guy, and today we're going to take a look at a 10-minute video on Introduction to Logarithms. So for a quick and easy kind of a definition or description of a logarithm or a logarithmic function, a logarithmic function is just an inverse of an exponential function. So logarithmic functions are inverses of exponential functions. So you can see here on this graph I have this y equals 2 to the x power, which is graphed by this white function. Remember, as it gets closer to the x-axis, or it gets closer and closer as it moves to the left, and then it goes up really quickly there after getting in quadrant 1. And then this blue line represents the line y equals x, and an inverse is a mirror image of that. So an inverse is where you switch your x and your y values, or you switch your ranges with your domains with ranges. So this time you have x is equal to 2y. And when you plug in numbers, the yellow curve is what your graph looks like. And you can see the white and yellow are mirror images or are inverses of each other. So simply put, a logarithm is just an inverse to an exponential function. So since there is a relationship between logarithms and exponential functions, or logarithmic functions and exponential functions, let's learn first how to convert between logarithmic form to exponential form. All right, so this first example that I have, this is read as the log of 125 in base 5. All right, so log of 125 in base 5 is equal to 3. If I want to convert this to an exponential form, or it's simply this. It's 5 is that base number to the third power, what it equals 125. So I kind of tell people it makes this almost this counterclockwise type of rotation. 5 to the third power is equal to 125. So in the next one, again, it is read the log of 3 in base 3 is equal to 1. This would be 3 to the first power is equal to 3. All right? And this last one down here, you might be thinking, oh no, there's not a base. If there's not a base, it's called a common logarithm. Common logarithm means the base is automatically a 10. Kind of like if we were talking about radicals and we didn't see a little index, it would mean square root. Well, if you don't see a base number there, it means base 10. So this is 10 to the second power is equal to 0.01. Or you could think of this as 1/100th. Again, we have this, see this little pattern, start at the base. So 3 to the first is equal to 3. And 10 to the second is equal to 1/100th. So let's take a look at maybe 3 problems that might be a little bit more difficult. Just converting logarithmic form to exponential form. All right? This is very important that we understand how to convert, because when we want to start evaluating logarithms, we need to be able to convert in our minds or even on paper to an exponential form or to exponential form, and it might be able to help us to evaluate easier. So this one right here, if I want to convert this to an exponent, it is simply 9 to the fourth power is equal to 6,561. All right. This one right here, start at the base number, so it says log of 1 over 64 in base 4 equals -3. That's how you say it. So it is 4 to the -3 power is equal to 1 over 64. All right. And then this one right here, start at the base number, so it's log of 1 in base 2 equals 0. It's just 2, start at the base, to the 0 power is equal to 1. Now, let's take a look at how to convert from exponential form to logarithmic form. All right, so here are 3 problems where we have it in exponential form and we want to convert it to a or logarithmic form. So we say this. We're going to say, well, this is the log of 2,401 in base 7 is equal to 4. Again, we have kind of a pattern going here as well. We start at the 7, we go to here, and we end there. So it's this kind of counterclockwise pattern that we see again. All right, so in this one right here, if I'm going to convert it to a logarithmic form, it's the log of 1 over 32 in base 2 is equal to negative 5. All right, so kind of starting this is the base number, okay, the base with your exponent, 2 to the negative 5th, it's the base number over here. All right, and this one right here then is going to be log of 1 million in base 10, but we don't need to put the base 10 because it's assumed if there's nothing there, is equal to 6. 10 to the 6 is equal to 1 million. So this is very important that we learn how to do, just converting from logarithmic form to exponential form and from exponential form to logarithmic form. Next, let's take a look at how to evaluate logarithms. All right, so we laid us out 3 example problems here. The first one says, and it reads, log of 8 in base 2 is equal to what? All right. Well, if you're able to convert, you would know that this in an exponent means this, 2 to some power equals 8. 2 to what power equals 8? Yeah, 2 to the 3rd power. So the answer then would be 3. We've evaluated. We figured out what log of 8 in base 2 is. Same thing for this next one. Look at it. If you converted this to exponential, it's 5 to what power equals 25? Well, 5 to the 2nd power is 25. So the answer is 2, right? 5 to the 2nd power is 25. This next one, it says 2 to what power equals 1/4? Now you might have a little trouble with this one. 2 to the 0 power is 1, so it's got to be less than that. Yeah, it's a negative. It's a negative 2 because 2 to the negative 2 is the same thing as 1 over 2 squared. And 1 over 2 squared is just 1/4, right? So this is why it's important to learn how to transition from logarithms to exponential form and exponential form to logarithmic form so we can evaluate. Let's take a look at a few more evaluations. All right, 4 more. This first one should be the easiest of the 4. Log of 81 in base 9. Again, thinking of exponents, it's 9 to what power equals 81? Well, that's easy. 9 squared is equal to 81. On the next one, this one might be a little bit tricky. You got 1/2 to what power is equal to 32? Well, if you put any kind of a positive integer there, it's just going to make it a really small number. 1/2 squared would be 1/4, all right? So it's going to have to be a negative number so we can get the 2 in the numerator. And it's going to be to the negative 5 power because 1/2 to the negative 5 is the same thing as 2 over 1 to the 5th. And 2 to the 5th is 32. This next one's just with variables. B to what power equals 1 over b? Well, it'd be negative 1. All right, b to the negative 1 is the same thing as 1 over b. It's also good to maybe review on exponential rules or properties of exponents. And this last one's b to what power equals 1? Well, anything to the 0 power is equal to 1. So that one is 0. So here is just a quick video on an introduction to logarithms. Thank you. God bless.